Hi everyone, so in this video we're going to be talking about combinations. So a combination is a group of objects selected without regard to order. The number of combinations of n items chosen r at a time is n factorial divided by n minus r factorial times r factorial. So this should look pretty familiar. It's very close to the permutations one, except for it also has this extra r factorial on the bottom. That's the only difference though. So to start out, let's go ahead and do some combinations. So starting out with 7c3. So remember 7 is our n, 3 is our r. So it's going to be 7 factorial over 7 minus 3 factorial times 3 factorial. Right, so 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 minus 3 is 4, so that's 4 factorial. 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. And then we're just going to cancel anything we can. So 4, 3, 2, 1 cancels out in top and bottom. But we can also cancel a little bit more. So the 6 and 3 can both be divided by 3. That would leave us with a 2 up there. But then the 2 and the 2 can cancel. So the only thing actually left is 7 times 5, which is 35. Okay, so that one's kind of a little bit more of a pain. It's a little bit more to simplify than just the permutations one, because we can't as easily cancel everything out. So once again, I'm going to let you off the hook a little earlier this time. We can use Desmos or a TI-83 or 84 to do these. So for part B, it is 12C8. It's going to be the exact same process in the TI-83 and 84. You would put in the 12, go to Math, Probability, and this time choose NCR, and then put the 8 on the right side. That will get you to the correct answer, and I will go ahead and show Desmos right now as well. Okay, so this time we are wanting 12C8. So again, we can go to Functions, go all the way down to the Number Theory category, and we see NCR. Click that. We're going to put in 12 as our N, comma, 8 as our R. And we get 495 in this case. So 495 is our answer. All right, for 5C5, same exact idea. We're going to go over to Desmos again. And in this case, instead of actually going through the functions, don't forget you can also just type this in. So it's N, capital C, R, open a parentheses, and if we want 5C5, then we put 5 comma 5. And we get 1. So that one is just 1. All right, last one. Let's try it out. 6C4 divided by 11C4. Again, go over to Desmos. And we can put this whole thing in one line if we want to. So again, NCR, it was 6C4 for the first one, divided by NCR, and it was 11C4 for the second one. Just make sure you put those commas. So it is 0.0454545 repeating. So we'll say it's approximately 0.045. All right, so again, just like the permutations, you will need to know how to do it doing those factorials, but for most of these problems, you can just go ahead and plug it into a calculator. All right, so let's look at number 10. Myrna has 12 DVDs that she really likes. Of these, she is taking 4 on a trip. In how many ways can she choose the 4 DVDs? So the key here is she's taking 4 of them on a trip. It doesn't matter which one she packs first or second. She's going to take all 4. So order does not matter. That's your clue that it's going to be a combination, right? So if order does not matter, it's a combination. From there, it's nice and easy. Out of 12, she's going to choose 4. And then you get to just plug this into your calculator. And we should get 495. All right, number 11. From a list of 15 books, students in a literature class must read 3 of the books and submit a book report. In how many ways can the books be chosen? So in the end, you have to pick 3 books. It doesn't matter what order you pick them in, you're still going to have to submit 3 reports. So again, order does not matter. So, if order does not matter, that means it's going to be a combination. Out of 15 books, we are going to choose 3 of them. And then we just plug it into our calculator and get 455. All right, to win $1 million in Texas playing Powerball, a person must select the 5 winning numbers where the numbers range from 1 to 69. The order in which the numbers are chosen is not important. In how many ways can the 5 numbers be chosen? So, this one even pretty much tells you the order in which they are chosen is not important. So, order does not matter. So in this case, there's 69 numbers to choose from, and out of those, we can just choose 5 of them. Plug that into your calculator. We get 11,238,513. That's the total number of ways that you can pick 5 numbers. That's the total number of possible lottery tickets in this case. Number 13. How many 5-card poker hands are there, given that there are 52 cards in a deck of cards? Alright, so not sure how many of you are poker players out there, but the one thing of note in this problem is that out of 52 cards, you are being dealt 5 of them, and the order that they are dealt to you doesn't matter. Once they're in your hand, you can move them wherever you want, and it doesn't matter. So order does not matter. So again, a combination. So out of 52 cards, we're going to choose 5. Plug that one into your calculator, and we get 2,598,960. All right, next one's going to be a little trickier. So a committee of 4 instructors and 3 students is to be formed from a group of 7 instructors and 11 students. In how many ways can this be done? All right, so the key to this one is knowing that we're kind of looking at two separate problems. We are looking at picking 4 instructors out of 7, and we're also looking at 3 students out of 11. So we're going to do those separately, and then all we're going to have to do is we just use the same rule of counting that we did last time in the last set of notes, and we're just going to multiply those together. So the number of instructors out of 7, we're going to choose 4, because again, order does not matter. In the end, you are either going to be on the committee or you are not. It doesn't matter which order they were picked. For the students, it is going to be out of 11, we're going to choose 3. All right, now at this point, you can either do both of these separately and then multiply those two numbers, or in Desmos, if you want to go ahead and put it all in as one big thing and let it do all the work, you can do that as well. In this case, though, I will go ahead and work out both of these with the calculator just so you can see both the numbers, just in case you might have had a typo somewhere. So these numbers are 35 for 7C4 times 165 for 11C3, and if you multiply both of those together, you should get 5,775. All right, last question, and hopefully this is a nice and easy one at this point. What is the difference between a permutation and a combination? For a permutation, order matters. For a combination, order does not matter. That's the big difference. And just remember to plug them into your calculator. This one's in PR, and this one will be in CR. And that's it for the video on combination. Thank you for watching.